Welcome back to Blockchain Technologies. In the last few videos, we covered mining, currency, and data storage, the plumbing of the blockchain. Today, we look at what makes blockchain useful, smart contracts, and the peer-to-peer network that lets them run without anyone in charge. By the end of this video, you will know exactly how a piece of code can enforce an agreement automatically and how thousands of independent computers agree on outcome without a central server. Now we are going to see about definition of the smart contract. A smart contract is just a program stored on a blockchain that runs automatically the moment its conditions are met. Think of it as a vending machine. Insert the right coin and the machine cannot refuse to give you the snack. There is no cashier to argue with. That's the whole idea. If the payment received, then release the asset. And it happens without a bank, a lawyer, or an escrow agent in the middle. Three properties matter here. It's self-executing. No one has to trigger it manually. It is tamper-proof. Once deployed, nobody can quietly edit the logic. And it's transparent. Anyone can read the code and verify exactly what it will do. Now we are going to see about how a smart contract executes. You're seeing in the slide four step flow, right? Here is the life cycle in four steps. First, someone writes the contract code and deploys it to the blockchain. From that point on, it has a permanent address. Second, a transaction or an external event triggers one of its functions. Say someone sends a payment. Third, and this is an important part, every node on the network independently checks that the conditions are actually satisfied or not. Nobody just takes the contract's word for it. Fourth, if everything checks out, the outcome executes automatically and gets returned to the blockchain forever. No step requires a human to approve it. Now we are going to see about smart contracts in the real world applications. This is this isn't just theory. This isn't just theory. Smart contracts already run real money. In DeFi lending, loans issue and get repaid automatically based on collateral rules. No loan officer involved. Parametric insurance can pay out a flight delay claim that instant flight data confirms the delay. No claims adjuster. No paperwork. In supply chains, payment can release the moment a shipment is confirmed delivered. And with NFTs, a smart contract can pay the original creator a royalty automatically every single time the piece of resold. Now we are going to see about where the smart contracts run. Ethereum is the platform that made smart contracts mainstream. Contracts are written in Solidity and run on the Ethereum virtual machine, and there are now thousands of applications built on top of it, from finance to gaming to digital art. But Ethereum isn't the only option. Hyperledger Fabric targets permissioned enterprise use cases where contracts are called chain code. Solana focuses on high throughput contracts written in Rust, and Polkadot lets contracts operate across multiple chains at once. Different platforms but same core idea. Next, we are going to see about peer-to-peer network. So smart contracts execute automatically, but where there is no company server running them. That's where peer-to-peer networking comes in, and it's the second half of the today's video. What is a peer-to-peer network? In a peer-to-peer network or P2P network, every computer, every node is unequal. Each one can store data, share it, and talk directly to other nodes with no central server coordinating anything. Three things define it. Peers are equal, with no node holding special authority. Sharing is direct, node to node, without a middleman server, and the network grows organically. A new computer just connects to a few existing peers and it's part of the network. This is a diagram which shows the node who connects to every node. Every node will connect to every node. Now we are going to compare the P2P versus client server. Compare that to the client server model most of the internet uses, like a website. One central server holds the data and every client connects up to it. That's simple, but it has a weakness. If the Think of it, if the server goes down, everyone loses the access and whoever owns that server controls and can restrict. Who gets in? No one can gets in. A peer-to-peer network flips that. Every node holds its own copy of the data, so there is a no single point of failure and no single owner who can control access. That's the architecture blockchain is built on. Now we are going to see about how blockchain uses a P2P. It is a four-step process flow. New transaction, spreads it, nodes validate and add it to a block. Here is the exactly how that plays out for a blockchain transaction. A node creates a new transaction and broadcasts it to the peers it's directly connected to. Those peers relay it onward to their peers. This is called gossip. Until the entire network has seen it, along the way, every node independently validates the transaction against the rules. Once it's valid, miners or validators include it in a new block, and that block spreads across the network the exact same gossip way. This is why blockchain data doesn't need a central authority to be trusted. The network reaches agreement on its own. Let's zoom out on why this architecture is the right choice for blockchain. It gives resilience. The network keeps running even if a large number of nodes drop offline. It removes any single point of failure. There is a no server an attacker can simply take down to stop the system. It gives censorship resistance. No single party can block or reverse a transaction. And it keeps participation open. Anyone with the right software can join as a node and help run the network. So here's how these two ideas connect. A smart contract's code and its current state are replicated across every node on the peer-to-peer network. When it executes, the whole network independently agrees on the result. No server, no single owner, no single point of failure. To recap, smart contracts are self-executing code triggered by conditions. P2P networks means every node is equal with no central server, and together they let blockchain run trustlessly anywhere in the world. Okay, thank you.